Hey everybody, it's Sanyukta from Vista InfoSec. In this video, we are talking about 2021 OWASP Top 10, and this is the number 2 security risk, and that is cryptographic failures. Today, we will discuss why cryptographic failure is considered one of the most common application security threats and its standard form of attack and preventive measure. So let's get started. The agenda of today's session is understanding overview of cryptographic failure. What is cryptography? What is cryptographic failure? What leads to cryptographic failures? Impact of cryptographic failures. Some example of cryptographic failures, vulnerability exploitation, and how to prevent a cryptographic failure. So now let's understand what is the overview of cryptographic failure. OWASP Top 10 list was out in 2021, and as usual, it has enlightened us about the most dangerous and potential vulnerabilities. And cryptographic failure, that is previously known as sensitive data exposure, has occupied the second position in the list of OWASP Top 10 vulnerabilities. So what is this all about? As per OWASP, cryptographic failure is a symptom instead of a cause. Any failure responsible for the exposure of sensitive and critical data to an unauthorized entity can be considered as a cryptographic failure. There can be various reasons for cryptographic failure. Some of the common weakness enumerations, that is CWEs, are CW259, that is use of hard-coded password, CW327, broken or a risk crypto algorithm, and CWE331, that is insufficient entropy. Nowadays, computing systems play a significant role in every aspect of human activity. Every marketing software, banking, healthcare, and education application uses this computing technology. However, you might be curious about how businesses protect their data and maintain the privacy of their banking activities. So, cryptography is the answer to each of these questions. In today's connected world, sensitive information must be protected, which is why cryptography has influenced the current information age. Additionally, Gmail data is secured using cryptography and is transmitted throughout Google data centers in an encrypted manner. Cryptography is therefore regarded as the essential component for protecting shared information. Cryptography uses codes to protect data and communication, so only the intended receivers can decode and understand them. In cryptography, crypto indicates hidden and graphy indicates writing, respectively. The techniques used in cryptography to secure data are based on mathematical principles and a set of rule-based calculations known as algorithms to modify signals in a way that makes them challenging to decode. These algorithms generate cryptographic keys, create digital signatures, safeguard data privacy, enable online browsing on the internet, and ensure the confidentiality of private transactions like credit card and debit card payments. So, there are three main types of cryptography: symmetric key cryptography, asymmetric key cryptography, and hash functions. So, what is symmetric key cryptography? Symmetric key cryptography, it is an encryption technique. The sender and recipient use the same shared key to encrypt and decrypt messages. Although symmetric key systems are quicker and easier to use, they have the drawback of requiring a secure key exchange between the sender and the receiver. Data encryption system, that is DES, is the most widely used symmetric key encryption method. Hash functions. In this algorithm, no key is used. The plain text is used to produce a hash value that has a fixed length, making it challenging to retrieve the plain text information. Hash functions are widely used by operating systems to encrypt passwords. And the third type of cryptography is asymmetric key cryptography. This approach uses a set of keys to encrypt and decrypt data. Public keys are used for encryption, whereas private keys are used for decryption. The public key and private key are different from one another. Even if everyone knows the public key, only the intended recipient may decode the message, since only he can access the private key. Since cryptography is used so widely and has many different implementations, there are several ways for vulnerabilities to occur. This could be through implementation errors, using weak encryption methods, not encrypting data at all, and much more. Therefore, a cryptographic failure vulnerability is a broad vulnerability category that contains all types of attacks that are related to anything cryptography related. As one could imagine, a vulnerability of this type could lead to serious consequences as cryptography is meant to secure sensitive information. Thus, if there is a failure at any point in this process, this information could be exposed to any number of malicious attacks. A cryptographic failure is a critical web application security vulnerability that exposes sensitive application data on a weak or non-existent cryptographic algorithm. Those can be passwords, patient health records, business secrets, credit card information, email addresses, or other personal user information. Modern web applications processes data at rest and in transmit, which require security controls for threat mitigation. Some deployment employ weak cryptographic techniques that can be cracked within a reasonable time frame. Cryptographic failures are where attackers often target sensitive data to gain the access of their personal informations, and this is the root cause of sensitive data exposure. In general, cryptographic failures fall into three categories: confidentiality breach, integrity breach, and availability breach. Confidentiality breach happens when a third party is able to access confidential data or when an organization discloses data on accident. Integrity breach. Integrity breach describes a situation when sensitive data is altered once again without authorization or intent behind it. Availability breach. What belongs to this category is scenario where sensitive data is destroyed or when you lose access to it. The category covers both permanent as well as temporary data losses. Now let's understand what are the security flaws that commonly lead to cryptographic failures. Cryptographic failures happen because organizations don't handle certain information the way they should. At times, you can find sensitive data in plain text documents left unattended. Of course, when sites don't enable HTTPS security and don't secure the connection via SSL, the web pages and apps that are stored sensitive information will always be vulnerable. Apart from that, when you store sensitive data in an insecure database, you can also easily expose it to intruders. To elaborate, an insecure database is any database that can fall victim to attacks like SQL injections, uses a weak cryptographic algorithm or a key, doesn't implement hashed and salted password practices, and or stored data in a multitude of other insecure ways. As you know, SQL injection attacks are code injection techniques that let hackers interface with the queries that apps makes to their respective databases. You can use this technique to appropriate data from the infected database through the backend. By the same token, when you store hash passwords without salt means read when they are not under full cryptographic protection, making them easy to encrypt. Passwords can be exposed as well. Hashed and salted passwords, on the other hand, are converted into word puzzles during storage. Puzzles that only the server they are stored on know how to intercept, but when organizations use second-rate hashing, hackers can easily read these passwords during a cryptographic failure. On that note, let's look at the few examples of cryptographic failures. Simple example with man in the middle attack. For Here, the attacker is able to view all the information the user is sending to website, possibly including things like the credentials for their bank account. This is all because the website failed to implement the necessary cryptographic controls for preventing the attack. Imagine if a banking website did not use HTTPS. To give some context, HTTPS encrypts traffic being sent between the user and the website are opposed to HTTP, which sends everything in the clear. This is very important considering things like passwords, social security numbers, etc. could be communicated between the user and the website. Using HTTPS means an attacker would not be able to view the information being exchanged if they were to intercept the traffic. Therefore, failure to use HTTPS would make users vulnerable to what would be called a man-in-the-middle attack. As the name suggests, this type of attacks happens when attackers is able to intercept traffic between two nodes and view the information being exchanged, usually possible by being on the same network. Now let's take a real life example. In the real life example of Facebook. In the suite pre-COVID 2019, it was revealed that over 540 million records related to Facebook users were accidentally leaked by two third-party Facebook app developers. These apps, without any malicious intent, posted the records in very much plain sight on Amazon's cloud service. The exposed records included Facebook users' account names, IDs, friends, photos, location, check-ins, and passwords. Unfortunately, that wasn't the first nor the last time Facebook has exposed this sensitive information. A month prior, Facebook found that the passwords of about 60 million users were stored internally in plain text for months. A few months before that, the same book of faces revealed that data on millions of users had been harvested by data science company Cambridge Analytica. How cryptographic failures impact on a web application. Poor cryptography directly affects the security of an application and its data. Lack of security can let attackers steal and modify data to conduct fraud and identity theft, which can lead to serious consequences. The impact of cryptographic failure is not limited to stealing a piece of information from or of a user. Attackers can get hold of a complete database having thousands of sensitive information, data theft, public listing, breaches, and many critical problems with a business-related data. Attackers try to steal keys, execute man-in-the-middle attacks, or steal data from the server in transmit or from the browser. This again leads to compromise in sensitive information. Now let's see some of the examples of vulnerability exploitation. So this is the first example of vulnerability. Here we are using the Portspear website for vulnerability. The first lab is source code disclosure via backup files. This lab leaks source code via backup files hidden in a directory. So to browse this lab, we need to first check the robot.txt file is disclosing or not. If it is disclosing, then we have to we have to browse the paths which will reveal the sensitive data of the files. So first we just check in URL that the robot.txt file is visible or not by entering robot.txt in URL. I just hit the enter button, and here the robot.txt file is disclosing, and it is disclosing the backup file path. So we just take this request in burp to check the backup file. The backup file is disclosing any sensitive file which is inside it or not. So I just hit the request and repeater and just normally take robot.txt path in a get request and hit enter. So now previously we have checked that the backup file is disclosing. Just replace that robot.txt to backup and hit enter. So it gives us 200 OK response, and in response the product template.java file is disclosing, and this file includes a sensitive information of users. So we take that path and just replace the backup in URL to product template java file and hit enter, and we got the response. And here the sensitive information of code is disclosing. We just normally copy that code and paste that code as a solution of this lab, and the lab got solved. Now let's see the second example of vulnerability, which is information disclosure in error messages. This lab reveals that it is using a vulnerable version of a third-party framework through error messages. In this lab, we just have to take the product ID request in BUR and just manipulate that ID by using any type of string, where when we manipulate the string, we'll get an unexpected type causes an exception type error, and by using that error response, it reveals the lab is using a third party framework which is a vulnerable version. By using this we'll get a error message. By using this we'll get an answer. So I just take the second product ID request in BUR, and here I am sending that request to the repeater. After sending request in repeater, I just normally send that request and will get a 200 OK. Now I normally manipulate that product ID to a string like hacker in double quoted and hit that request. After hitting that request, there is a internal server error which we wanted. Now I just scroll down, and here it is disclosing the Apache 2.2.3.31 version, which is a third party framework version, and it is a vulnerable. So I just copy that answer and paste it in a solution of this lab. So normally I'll make the intercept is make sure the intercept is off and paste it again. Here I paste it and refresh. I'll get the congratulations, you have solved the lab notification. So the lab is get solved. Now let's see the third example of cryptographic failure vulnerability. Here I am using a Altero-Mutual web application. It is a open source to detecting web application vulnerabilities and defects. Now I just click on sign in, and I know the credentials, that is username is equals to admin and password equals to admin. Now I am using Wireshark to capture the packet and to check the credentials which we are entering are going in an encrypted format or in a clear format. So I here enter the credentials again and capture the request in Wireshark. So we get logged in, and here in Wireshark we check for the HTTP protocol, where we can see the credentials are transmitted in plain or an encrypted format. So here is the post request of do login, where we can check that the user ID equals to admin and password equals to admin are transmitted in a plain text, and the packet captured properly that the credentials are transmitted in plain text. This is just because the website is using a HTTP protocol. It is don't enable it. The site don't enable HTTPS security and don't secure the connection via SSL. The web pages and apps store sensitive information, always vulnerable when we are using the HTTP protocol. After performing the cryptographic failure vulnerability exploitation, now let's understand how to prevent a cryptographic failure. First, encrypt all data in transmit with secure protocols such as TLS with forward secrecy ciphers, cipher prioritization by the server and secure parameters, enforce encryption using directives like HTTP strict transport security, that is HSTS. Do not use legacy protocols such as file transfer protocol and simple mail transfer protocol for transporting sensitive data. Store passwords using strong adaptive and salted hashing functions with a work factor. Ensure that cryptographic randomness is used where appropriate and that it has not been seeded in a predictable way or with low entropy. Avoid deprecated cryptographic functions and padding schemes such as MD5, SHA1, PKCS version 1.5. So these are the preventions and we can say mitigations for cryptographic failure. By using this, we can avoid our web application to be vulnerable to cryptographic failure. Okay, so this is all about cryptographic failure. I hope you enjoy this video, and I will see you next time while covering the other vulnerabilities from the new OWASP top 10 list. Thank you.